Hi everybody. So today I want to talk about resistance. Um, you'll have to bear with me. This is my first time doing like a video of me not standing in front of a board, so I will do my best, okay? But basically, resistance, when we're talking about resistance within an electrical circuit, we're talking about like resistance to like the flow of charge and like current, right? So resistance is something you want or you don't want in certain situations. The first formula I'm going to give you is one formula for resistance. So that's an R. And this is equal to rho L over A, where rho is what's called the resistivity. Now, resistivity is a material property. Resistivity is more like certain materials are prone to have higher resistivity than others. This can be a good thing. This might not be a good thing in certain situations. What you need to know is that resistivity, the units are the ohm meter. So it'll look something like this. And excuse my handwriting, just bear with me. This is an ohm, this is a meter, okay? So basically you'll see that it cancels out when we have our area and length taken into account and everything. But what you will end up seeing is that resistance has units of ohms. So that little omega, I guess big omega, is ohms. That's and 1 ohm is the unit of a resistance. You will see that certain things obviously can like change this whole equation, right? The bigger I make my L, the bigger my resistance is going to be. The bigger I make my resistivity, the bigger my resistance is going to be. The smaller I make my A, the resistance is going to be higher. And one thing I should mention is that this is cross-sectional area. A lot of the times we're going to be dealing with like maybe wires. So obviously current flows through those wires and everything. So this A stands for cross-sectional area. One other thing you need to know, temperature can also affect resistance. The higher the resistance, you're going to have, like the higher the temperature rather, the more resistance you're going to have in a fluid. So, yeah. The next formula I want to give you is another one for no, I'm sorry. It's actually, it has resistance in it, but it's for voltage. And this says that V is equal to I times R, okay? Where this V is our voltage, this I is our current, and this R is our resistance. Obviously, this voltage is going to have units of volts, okay? So this is called Ohm's law. It's pretty fundamental in anything that you're going to do regarding circuits, or in a lot of the stuff you're going to do regarding circuits, I should say. So just keep that in mind. I also want to talk about like internal resistance. I'm going to give you another formula for voltage, and this is given by E minus I, and a lot of the time they call this little r, and you might see this written as like E of the cell. So like E of the cell is equal to, V is equal to E minus I times R internal. This R internal is still it's our internal resistance. So let's say maybe you have like a battery or something. Certain like maybe like cells or batteries have internal resistance. That the way I look at it is like maybe like this EMF is sort of like, I don't know if this is the correct way to go about it, but the way I process it in my head is like this EMF, which is our electromotive force, it's sort of like our perfect voltage. So this EMF, it's good to note that this is given in volts. This is the potential difference of like a battery, I believe, when no current is flowing through it, right? So this EMF is like the voltage that they might give you, right? This I is still going to be our current, okay? But this R is going to be our internal resistance. So this might like cause, well, I mean, obviously, like the only way that this E and this V are going to be the same is that if this internal resistance is 0, right? And that's the way I look at it. If like there's no internal resistance, this is going to be a perfect like situation in which our V is equal to our E, right? So that's a good thing to keep into account. So basically, like your E is called your electromotive force. That's given in volts. And one more thing I want to point out actually is that this is given in volts. We know that I times R is equal to V, right? So that is also given in volts. So we're not like changing up units here. We're staying consistent with our units. So it's volts, 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 okay? The next thing I want to talk about is power. So you're going to see a formula for power used maybe quite frequently. And this is going to be given by delta E over T. And basically, this E is, and you might also see it given like this. This E is energy, okay? This W is work. Same thing, joules, joules, right? This is seconds, seconds. So this is joules per second, which is our units, which are our units. But a lot of the time, this is given by watts, which is given by W, okay? So basically, power is the amount of energy being transferred, or energy like work done in over a certain amount of time, right? Or per second, maybe I should say. Well, no, it's to time. So like, it's a ratio basically. So keep that in mind. Another formula for power we're gonna see is I times V. But we also know that that V is equal to I times R, right? So a formula for power can also be I squared R, okay? But we also know, bear with me, that P is equal to I, and I is equal to V over R, right? Times V, that's the same formula, right? So we get V squared R, V squared over R rather. So those are two formulas for power that you might need to remember, okay? I don't know if there's an intuitive way to go about it, but if you remember that power is equal to I times V, you should be fine because you're able to derive this and this, right? Now I want to talk about like resistance. Oftentimes you're going to be asked to calculate resistance, and it might be a little bit tricky at first. So let's say I have a cell, okay? So this is how I'm going to draw my cell. And let's say this is how we draw resistors. It's just a little squiggly line. Doesn't have to be perfect, okay? I'm going to draw two resistors here. Okay, and I'm going to complete my cell. So basically, this should actually, it's important to note that the cell, while electrons go, obviously they're attracted to the positive charges. Current actually flows from positive to negative. So it's important to keep that in mind, okay? So maybe this is like our I, okay? And this is my R1. Hold on. This is my R1, and this is my R2, okay? And obviously current is going to flow around this whole circuit, okay? Now, you might be asked to find the total internal resistance of something, okay? What you need to know is that your R total, so like first of all, I want you to understand that this is a series setup, okay? So this whole setup is in series because like it's one thing after the other. They're not like right next to each other, and you'll see what I mean by that later. So just know that this setup is called a series setup, okay? You're gonna be asked to find the total resistance for like a series setup at times, okay? So that R total is simply given by R1 plus R2. Sorry about that. Okay? Now, that's pretty intuitive, right? You just add them up. But this also gets a little bit tricky when we're dealing with like maybe parallel circuits. So I'm gonna draw something like this. Let me do this. So let's say I have a parallel circuit, okay? And let's say my circuit looks like this. Sorry, y'all, I'm not an artist. Let's say my circuit looks something like that, okay? Now I'm going to say this is my R1, this is my R2. Now, again, my current is flowing throughout this thing. But what I want you to realize is that I'm going to call this I1. According to Kirchhoff's junction rule, there's going to be a split here and a split here, okay? So obviously I have maybe I2, I3, where I1, is equal to I2 plus I 3. Okay? Now, what you're going to realize is that, remember I said resistance is like the opposition to flow, basically. If I'm correct, the one with the higher resistance is going to attract less of the current than the other. I also forgot to mention, this is a parallel setup, okay? Parallel. So this is obviously because like they're in parallel with each other, okay? While these ones are not. They're in series. They're one after the other, okay? So now, right, when might a parallel setup be useful? Basically, in your house, a parallel setup is used. If you turn off one light in your house, you don't want all of the lights to turn off, right? So a parallel setup is very useful for that. When you're asked to find the total resistance of a parallel setup, you're gonna find that rather 1 over R total is equal to 1 over R1 plus 1 over R2. Let's say I had maybe like another, right, like resistor, and let's say this was R3, and I had a bunch until I got to like Rn, okay? So like that's my nth resistor. I would find that R total is equal to R1, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 all the way to 1 over Rn, depending on how many resistors you have, okay? So, but that's only in the case that we have a bunch of resistors, okay? But this formula will hold up for any number of resistors in parallel. What you also need to know is that there's another formula when we have 2 resistors in parallel. Maybe you want to get a question a little bit quicker, because what happens a lot of time with this, you might forget to like divide 1 by, like, you might forget to solve for R total, and you think your total R is 1 over R. You solve these, you add them up, and you're like, okay, my R total is 1 over R1 plus 1 over R2. It's not. 1 over R total is that. So it becomes very easy to mix up. But another formula that you can use, this only works if you have 2 resistors, okay? R1 times R2 over R1 plus R2. That'll give you your total resistance, okay? Another thing I want to talk about is combining resistors. So let's say my setup looked something like this, okay? Let's say I had a third resistor here. So I'm now going to call that R3. So now, right, I want to find the total resistance of this whole circuit. So I want to find what's the total resistance here. We're going to do something what's called combining circuits. So I'm going to turn this circuit into something that looks like this. And that looks pretty similar to our original circuit here, right? Our circuit in series, right? So we're going to find that maybe the fewer resistors we have, right? I'm just going to say this is some V, okay? The fewer number of resistors we have, the easier it is to like not make mistakes. I mean, you're going to have to do this anyway if you want to find maybe the total resistance. But we're going to find that this R3 stays the same. Now this we're going to have to find the total resistance here. So I would combine these two into one resistor. And we know how to find the total resistance. For simplicity's sake, I'm just going to write that second equation. This would be my total resistance, right? Let me not say that. I'm going to make this R2 prime or something. I'll say that. R2 prime is equal to the total resistance of these two, right? But if I want to find the total resistance of this whole circuit, I now have to take those and do what I would do for resistors in series. So I know that my R total would be equal to R2 prime plus R3, which is going to be equal to R1 times R2 over R1 plus R2, right? And that's going to give us our total resistance. So really, when you have like multiple resistors in parallel and series, you're going to have to combine some things. Or if you have a bunch of resistors, in parallel and series, it's going to be a little bit easier just to combine these things. But basically, that's really, I think, all you need to know about resistance. It's really not that bad, okay? If you have something in series, you know it's simply equal to R1 plus R2. Parallel, 1 over R1 plus 1 over R2 plus blah, 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 all equals 1 over R. You have to combine them when it's a situation in which we have both. But that's really, I think, all you need to know. As always, please don't forget to like and subscribe. Go ahead and leave comments in the comment section if you have any difficulties or anything. And let's keep learning, okay? Thanks.